Time to look at refraction through lenses. You did the semicircular prism, and now we're going to move on to semicircular lenses. We've played with concave lenses, or mirrors, and convex mirrors. Now we're going to play with concave lenses and convex lenses. Now I did this to show you they actually sort of spoon. So what we're going to see is when the lens fits the mirror, this lens that is bulged out will have the same properties as the mirror bulged in. The mirror where it's bulging out will match the behavior of the lens bulging in. Or in other words, concave mirrors match convex lenses. So let's look at that first. You already discovered you could find the focal length of a concave mirror by bringing parallel beams in, finding the focus. It will even crudely work like that, but us teachers don't want you to do a lab in a second. We want you to take a whole class period, so we make you do it with multiple rays. If I remove the mirror and switch it with a lens, lo and behold, there's a focus again. But it winds up being a tad more complex. Again, these lenses have a frosted face. All right, if the frosting is up, you won't see the rays. If you put the frosting down, you can see the rays. The center of a lens is right here. So if we put our lens on the page, you see the beam comes right through. If you try to go up this way, the beam does come straight through, though you may get a slight breaking of the beam. Notice how it may come through parallel, but moved over. Okay, so setting this up, don't expect to get dead straight, but that's pretty close. Okay? So now you're going to go looking for the focus. To find the focal length, once again, you send in parallel beams. They seem to be crossing there. The farther out you go, the dimmer your results are going to be. So the closer you can come in, the brighter the beam. It's very important you follow the lines that I created on the page. Not barely, but dead accurately. And you're going to do the same as before. You're going to mark a spot. You know it was going in straight. And it emerged here to here. You can label it ray 1, whatever you want. When you're done the lab, you're going to do this. Notice they don't quite line up. Now, when does the bend occur? At what point should I bend the rays? Well, take a look at my diagram. Okay. This lens shape is irrelevant. What matters is the center line in the lens. Right along there. That's where you bend the beam. So if I take this and extend it to the center line, and then do this, notice they fit perfect now. So you don't change the beam till you reach the center of the lens. Now let's confirm that. Let's put the lens back on. We'll do this straight through. And notice that's pretty much, it does bend a bit more abruptly in there, but for ray tracing, the only way you're going to pull it off is change the beam in the center. This means on most labs, what you're going to see is just this mark like this, and a mark down here, and a straight line for the lens. So ignore the body of the lens completely if it appears on a diagram. You will only see me providing the body of the lens on this one single lab, never anywhere else. The last thing I want you to do with the lens is it says interesting observations. Once you confirm with a minimum of 3 parallel rays is what I want to see, where the focus is, and you write down the focal length, I want you to start going incredibly off axis, as far as you can. No spoilers. Keep on going down till you're way down here, and I want you to write what the lens is doing to the ray, something that has not so far been discussed. And the mirrors did no such thing. I took the lens away because I want you to discover it. Then when you're done that lab, you're going to move on to this lens. And you put the lens down. Same thing again. Make sure you don't have the frosted side up. We want to find the center. Looks good. And again, this lens is going to scatter the light. So the focus is going to be on the opposite side. You see right here. It's all spelled out at the top of the page. So once again, you're going to send in parallel beams like this. You'll mark where it looks like it came from to there. When you're done, remove it and you draw your parallel line in to the center. Okay, the center is right there, straight down the middle. And you go in and find this beam here. Follow it right to the middle before you change its angle. That is the real light. But your brain, if your eyeball is sitting out here somewhere, your eye, you may know by your intelligence that the light came from over here, but your eye is simply going to report to the brain, incoming light came from back here. So the virtual beam, you extend it back here like this. This is the imaginary light. It's often drawn as a dotted line. I don't have that kind of time. Okay? So you're going to locate the focus exactly as you see presented there. You can also confirm the center works. You will tell me the focal length, and then once again, when you're done, I want you to bring the light really close, and as you go extremely off axis, way up here, I want you to see if anything interesting happened.